Hello, everyone. I am Christopher Chianelli. I am a software engineer for OptaPlanner. The main project I work on is OptaWeb Employee Rostering, which is a web application that allows you to plan your employees' schedules. And today I am going to talk to you guys about visualizing indictments. So how to create an explanation of the solution OptaPlanner gives you and feed it to your user. So we will begin with what is score visualization. Then we will talk about indictments and constraint matches, what they are and how to get them. Then we will talk about some tips about visualizing the score. And then we're going to talk about how to identify deficient resources using indictments. And finally, how you can actually identify misbehaving constraints from the visualizations. Finally, we will just sum it up and have a Q&A at the end. So, what is score visualization? So, you have created a solution for your fitness problem, but when you show it to the user, you're at the following questions. So, why isn't Amy working on Monday, for example? Or maybe you're asked, is it possible to hire additional workers? Or maybe, what will happen if Bob worked 5 days in a row? If you're given only the solution, it is hard to answer these questions because they require insight to how the problem interacts with the constraints. So we do know if the solution that OptaPlanner found in irregular time, but we want to know why OptaPlanner thinks the solution is good. Answer to that is score visualization. So score visualization refers to a variety of techniques used to visualize the score impact of planning entities. Use cases include being able to quickly tell what constraints a particular entity satisfies. So for instance, you get to learn that a shift, because it is assigned to Amy, you have to satisfy her desires to work on that day, or maybe she doesn't want to work on that day. You can also visualize improvements that can be gained by additional resources, so that will be useful for business decisions, such as purchasing an additional vehicle or hiring another worker. And finally, you can use it to check for misbehaving constraints. For instance, you may be double counting a constraint, calling it to be rate double its constraint rate. So just to give you a quick example, in the schedule below, order any employees working multiple shifts at the same time. It may be hard to see right now because there is no visualization whatsoever. But if I were to highlight any shifts that break that constraint, the question becomes easier to answer. So, how do we get the information from OptaPlanner? So, as you all should know, every solution has a score. If you do incremental score calculation, so joules or constraint stream, the score is the sum of all constraint matches. So what is a constraint match? So whenever a constraint is matched, so in this instance, no overlapping sets, a constraint match describing the constraint match is created. So over here, we have a constraint match. If for the constraint, no overlapping set, the justification risk is shift 1 and shift 2, because these two entities cause this constraint match to happen. A total impact to the score is -1 hard. Entities and problem facts can be in multiple constraint matches. So over here, shift 2 overlaps with both shift 1 and shift 3. So it will be involved in both constraint match 1 and constraint match 2. Over here we see SIF 1 and SIF 2 in the justification risks, and over here we see SIF 2 and SIF 3 in the justification risks. And then we also have a constraint match total, which counts how many constraint matches there are for a particular constraint. So constraint match 1 and constraint match 2 go into the constraint match total for no overlapping sets. And we see its score is the sum of its two constraint matches or minus 2 hard. And then we also have the other side. So instead of counting it from the constraint, we can also count it from the planning entities or problem facts. So over here, we can see that we have an indictment for SIF 1, and SIF 1 it only involved the constraint match 1, and total impact to the score is minus 1 hard. SIF 2 and SIF 3 also have indictments, and for SIF 2, it will include both constraint match 1 and constraint match 2, and the score will be minus 2 hard. So, in order to summarize the relationship, every constraint has a one-to-one relation with a constraint match total, which can have many different constraint matches. And indictments have pretty much 0 to many relations with constraint match, and they may or may not have a justification, where it will be an entity or problem fact. And each constraint match has a justification risk, where it will also be an entity or problem fact. So how do we actually get the information to OptaPlanner? If you're using the theme view sorter or you're using the Cockets, then you can inject score manager. We have a theme score solution method. If you're not doing that, you can also get it from the score director factory. The two important methods are get constraint match total map, which maps constraints to the constraint match total, and get indictment map, which maps planning entities to their constraint matches. So when should you use a tool? You should use constraint match totals when you want a summary of your constraint matches. So maybe you want to enter a question, how many PTO requests we were able to satisfy? In that case, we will do explain score of a roster. Then we are going to get the constraint match total map. And now we are looking particularly for the constraints day off requests. And we are going to get the count of how many times that constraint was satisfied. And that would be how many PTO requests we were able to satisfy. Or maybe your question is a little bit more complicated and is about the score. In this case, maybe we have a fuel cost constraint and we decide to make it one shop score equal $1 spent on fuel. In that case, then you can obtain the score of the route. And then we get the constraint match total map and get fuel costs. But now instead of getting the count, we simply get the score. Then after we get the score, we get the total fuel costs, and that would be the soft score. You should read indictments when you want information about a particular entity. So, for instance, maybe you want to know how does the current assignment of the morning shift impact the score. In that case, you simply change score again, but instead of getting the constraint total map, you get the indictment map. Then you get the morning shift. And then you simply get the score, we will tell you how much this shift impacts the score. Or maybe you want to Join. Then you want to find out who want to join OptaPlanner meeting but cannot attend due to a conflict. This is a little bit more complicated, so we actually need to do a variety of things. First thing, we get the indictment for the OptaPlanner meeting. Then we get the constraint match set for the indictment, so we get to see everywhere where it is violated. And then we are going to filter it in order to get the constraint that a desired attendee cannot attend. And then we are actually going to look at a justification list. So in this case, our constraint look like config factory.run talk.join attendee. And the constraint streams that we could talk about tomorrow. But this pretty much allow us to get what actually caused this constraint match to fire. In this case, we want the attendee, so we are going to get that. Then we are going to crack it into a list. So I'm now going to give you some tips about actually visualizing the score. So you have to be very information overload. So you want to make things that are important to the user stand out. Because you will get a lot of information, some of the constraint matches, and the indictments, but not all of them have the same importance to the user. So one thing that you should be aware of is you definitely want to make it easy to see the difference between soft constraints and hard constraints. We want the hard constraints to stand out to the user because they represent things that make the schedule or your problem infeasible. So how do we do that? I can use a different color for hard constraints. You that want to make sure it pops and stand out. And something else you can do is you can add icons in order to make it easier to see what hard constraints in particular are broken. You can also include a summary of constraints broken on top. But you do not want to go too overboard, because that can actually make it too cluttered and hard to tell important information. So in general, you should hide details that are not important to the user. And if you want to show the details, you should show them when the user inspects an object. So instead of summarizing all your constraints, you show the top 3 that have the most impact and hide the rest maybe in a dialog. And instead of showing all the constraints when an entity breaks, you show the top 2 and show detailed dialog when the user interacts with the entity. So what can we do else with code visualization? One thing we can do actually is identify deficient resources. So how we do this is using virtual resources. We represent a missing or lacking resources, or simply a resource we don't have. When a virtual resource is used, you penalize the score by how much it would cost to acquire that resource. So that is referred to for determining if there is any benefit to hiring a additional employee or buying additional vehicles. So in order to do this, you actually need to modify your domain. So over here, I have my employee class, but now I actually add 2 additional fields, costs, and it's virtual. Then I actually need to create a constraint for it. So here is a quick preview of constraint streams. So over here, I say get pretty much everything from the employee class. And I want to filter to include only virtual employee. I want to say if there exists a zip assignment to that employee, then I want to penalize it to for the constraint hire additional employee by 1 medium by employee costs. And now when you are actually using it, first you need to get your original problem. Then you are going to add your virtual employees to the problem. In this case, I'm adding a newness and a new doctor, they have different costs associated with them. And then I'm going to set my employee risk to my new employee risk. And then you can just solve the problem as normal. So one thing to note is the score level for the virtual resources constraint is crucial. If it is above all soft constraints, virtual resources won't be used if it is possible to solve without them. If you want to consider solutions that include virtual resources, even if it is possible to solve without them, put the virtual resource constraint on the soft score level. If you use virtual resources, limit the amount you add. Each virtual resource added slows down the solver. So pretty much you don't want to add thousands if you're not going to need thousands. So add a couple more depending on how many you think you may need. And finally, you can use code visualization to identify misbehaving constraints. So typically, constraint verifier is used to create unit tests for your constraints. But that only checks the correctness of your implementation, not that you implemented the constraint the business user actually wanted. So you may be wondering, how can this go wrong? Well, if for instance, it were to give you the following description of a constraint, two employees that do not like each other cannot work the same shift, it could be implemented as two shifts are the same if they share the same time slot. So over here, we are that joining shifts at the same time slot, and then you're filtering it to where the employees, the right sets contain one another. Or we could be implemented where two shifts are the same if they share the same spot and time slot. So over here, we add that there's no condition that the two shifts must be in the same spot. And it mean, what do I mean to be the same shift? Do you mean two shifts share the same time slot, or that two shifts share the same time slot and the same spot? So pretty much key takeaway here is you must have constant communication between the business user and yourself. That to keep getting updates and making sure that constraints you're implementing are what they actually wanted. So in summary, you can use score manager to obtain score, get constraint match totals, and indictments you can use to obtain the score. When you're showing the explanation in the UI, highlight important details and highlight more important ones. Use virtual resources to help identify deficient resources. And finally, you can use code visualization to help verify the constraint you implemented and what the user actually wanted. So thanks for watching my talk, and now we'll actually go to questions.